All right, so we know statistics is about using data to say something about a population. So let's talk about data. Data really just is our word in math for information. If we collect information, we're collecting data, and the type of data we're collecting determines the types of tools we're going to use to describe or explain or predict or whatever it is we're trying to do with the data. First distinction we want to look at is quantitative versus qualitative data. Anything that is a number is quantitative data, right? Quantity. Anything that's not a number has a quality rather than a quantity, so we call it qualitative. So if I ask you how many kids you have, the answer to that is a number, quantitative data. If I ask you what kind of car do you drive a car, do you drive a truck, do you drive a motorcycle, that is a quality, not a number, so that would be qualitative data. And you can see we need to use different tools, because if I say, this person has this many kids, that many kids, that many kids, we can average those together and say the average number of kids is. We can do that with quantitative data. With qualitative data, we can't really say this guy drives a blue car, that woman drives a red truck, he drives a yellow motorcycle, so the average just doesn't make any sense, right? We would say a certain percentage of the population drives this, that, or the other. So different tools for numbers versus not numbers. And the non-numbers are going to be fairly easy. We're going to finish with those pretty early in the course because there's not really all that much we can do with qualitative data. When we're looking at quantitative data, we again have to look at a property of the data to determine what tools we're going to use. And that's to look at, are we dealing with continuous data or discrete data? Discrete data is the easiest to deal with, and discrete just means that there are gaps between the data, or gaps between the possible numbers that you might have. For example, how many children you have. You have no kids, or one kid, or two kids, or three. You don't have 2.5. You go straight from 0 to 1, you go straight from 1 to 2, you go straight from 2 to 3. There's spaces between the numbers. That's the characteristic of discrete data. Continuous data is where you do have to go through numbers in between. In order for me to get from 4 feet tall to 5 feet tall, I have to go through all of the heights in between. I don't get to skip from here to there instantaneously. We call that a continuum when you have to go through all the numbers in between. So we call that continuous data or a continuous measure. It would be anything dealing with height or weight or time, because you can't skip from one to another instantaneously. You have to go through them. Okay, so discrete, there are gaps between the numbers. It doesn't have to be whole numbers. Think about our money system. We don't go straight from $1 to $2. We go from $1.01 to $1.02, $1.03, but there are spaces between those cents. We don't have $1 and 2.8 cents. We don't have a way to deal with that. So we get gaps between the numbers, discrete, no gaps, continuous. And we can use discrete measures for continuous data. For example, how long have you been alive? You're going to tell me 18, 19, 20, 35 years. You're not going to say 35 years, 2 months, 3 days, and 5 seconds. We just don't think about that in a continuous way. But your actual age is some weird number like that. But we'll use we'll use discrete measures to deal with those. One final distinction, and we're not really going to use these because we really don't care that much about these two on the outside. We care more about cardinal. The data we're going to be dealing with is going to be cardinal data, which measures how much of something or how many of something. How many kids you've got? 3, boom. That's how many or how much. How much money do you earn a year? How many hours do you commute to work per year? How much do you spend on baked beans? This is in the middle of the quarantining stuff, so I'm kind of obsessed with baked beans and frozen beef. Those are cardinal. Anything is how much or how many. An ordinal number is where you fit which child are you in your family. I'm the oldest, so I'm the first child. That's an ordinal number because I'm first in the order. What place did my team come in this last season? I don't have a team, but let's say they came in 8th. 8th would be an ordinal number because they were 8th in the order. And you can see how it's kind of useless to do math on ordinal numbers. If you take the first place team and the 7th place team, what do you have? You can't do anything with those numbers. They're just sort of, this one's here, that one's there. Whereas with cardinal numbers, we can compare them, we can add them, we can average them, all that kind of good stuff. The last one is nominal, and this is completely useless to us. We're not going to use it at all, but I want you to be aware that it does exist. A nominal number is just some number that's matched up with something. If you're a NASCAR fan, whoever drives car number 8, that's nominal number. It doesn't measure anything. It doesn't mean they're in 8th place. It doesn't mean they have 8 pit crews. It means that they are car number 8. Your social security number is a nominal number. Number doesn't measure anything. It doesn't say anything about you except that that is your number. Your driver's license number, your license plate number, number 17 on the football team, all of those things are nominal numbers. Nominal is just the same root as name, so it's kind of like your name. Skylar doesn't say anything about me. It's just the label that's attached to me, and that's what a nominal number is. It's a label number. Okay, so we've got arbitrary label numbers, which we're not going to worry about. We've got ordinal numbers, where you are in a list of things, and we've got cardinal numbers, how much or many. That's what we're going to care about, and why we care is because whether we're dealing with quantitative, qualitative, or continuous or discrete cardinal numbers, that's going to tell us what tools we're going to be using and what we're able to do with that data. See you later.